Here we go. All right, so first of all, thank you all for joining us this morning as part of this virtual tour of Solis for the Northwest Green Home Tour. We appreciate you all joining it on a Saturday morning, bright and early. And I think what we'll end up having is folks just kind of popping in as they want, and you can, I think, leave also when you want. So it's pretty casual this morning. We're just gonna kind of be here to answer questions. If we end up with a lot of people, hi Emily.
Good morning.
Good morning. We're just kind of doing general intro and just kind of giving everyone the lay of the land. So I was just mentioning that if we have a bunch of people join, we could also do breakout rooms if we end up with a large group and we want to have more intimate conversations. This morning we have representatives from Weber Thompson. So Emily and I work at Weber Thompson. We were the architecture firm for the project and also did landscape and interiors. And then we also have Sloan Ritchie, who is from Cascade Built. He was the builder on the project. And we have Mark Coluccio, who is from Solterra, and he is the developer on the project. So if we wanted, we could always break out into groups. So I actually am not the expert on the project. I'm the marketing person here helping this all come together. So I'm gonna actually maybe pass it over to Mark. And Mark, do you wanna just kick it off here? And I'll switch over to this other slide deck, and maybe you can give us a little bit of like the basic introduction for the project.
Sure. So Solis, renamed from a previous name, is currently the largest passive house in the Northwest. And I'm going to let Sloan talk about passive house because he's the expert on it. It's a multifamily building with retail on the bottom in Capitol Hill, 13th and Pike. We purchased the project from a group of other developers a couple years ago and built it. It's 45 units, as I mentioned. It's kind of market rate studio, 1-bedroom, 2-bedroom apartments. There was a moment when we were considering going condo, and the condo market did not pan out that well, so we flipped it right back to apartments. And it's it just got completed. So we got our certificate of occupancy only last month, and the building is now getting filled up with tenants, and it also has a hotel on the 3rd floor that's operated by a company called Sonder, and they've got people in and out of there all the time who are visiting Seattle or doing corporate relocations and things like that. So I'll turn it over to Sloan to talk about passive house.
Hello.
Look at that.
So,
good timing.
Yeah, so Passive House is a green certification program that really only looks at energy efficiency. It doesn't look at recycling or utility infrastructure or distance from where materials are brought. It really only looks at the operational energy of the building. And so this is kind of a funny picture to talk about what Passive House isn't. It's not funky earthship houses that are built partially underground. It's actually, like in our case, as you saw the earlier photograph, it's a very clean, modern, beautiful building with some advanced considerations and systems that make it consume a lot less energy than comparable buildings, just with a bit of extra forethought into the design and the way you air seal the building and advanced mechanical systems. You end up with a building that it has healthier air quality and consumes maybe on the order of about half the energy of a comparable new building. So that's kind of what Passive House is in a nutshell. Here's a house that we built maybe now 8 years ago or so. It was actually the first passive house we built in Seattle. And I'm actually sitting in that passive house right now, conveniently. That one, was the first one we had done. So there were some experimental things that went into it. But as you can see, it's just a pretty typical modern house. It's not like the earthship that was on the last slide. And we were able to implement these strategies, the air tightness, you know, the triple glazed windows, the sort of simple but high performance HVAC systems to make this house consume a small amount of energy. And then here's another project where it was townhouses, which are there's some row houses in the front and then units along the back. So we've got 5 units here that we sort of expanded on the ideas from the first project and bring it into a multifamily program. You know, doing the same passive house, the triple glazed windows, better insulation, reducing thermal bridging, improved air quality, heat recovery, ventilation, sort of all the HVAC elements that make the project consume very little energy. And then we wanted to scale it up even more, and that kind of brings us to today's project, which is this 45 unit apartment building. And we're just kind of demonstrating here from the construction side that these technologies are easily applicable to projects of any scale. And in fact, it's quite a bit easier on this scale than the last 2 projects were that we saw on the slides. So we're able to utilize a larger system to serve more units, to manage the heat recovery ventilation, and the air tightness and the density of units actually makes it easier to do passive house as compared to a single family or even like townhouse project. So we're finding that the larger the building, the better, really, from a construction standpoint.
I'm going to go ahead and put this on to maybe auto advance. And so we'll just let the slides kind of run through, and then folks from the team, you can jump in and talk about the slides at any point. And then people in the audience, you are welcome to turn on your camera if you feel like it. I know it's Saturday morning early, but we'd love to see your faces. And you can also interject with questions. This is meant to be kind of informal. So don't be shy. We'd love to know who you are and hear what questions you have and what you specifically want to know about the project. Hi, Scott. Good morning. I think I might have muted you. So
I muted myself.
Oh, okay.
Good morning.
Good morning. Do you have
Thank you all for doing this.
Yeah. Do you have any specific questions?
Yeah, I have quite a few. So I've been watching the building go up. It's beautiful, and congrats to the team. I think you guys did a great job. I'm just trying to think. One of the questions I have is around taking the next step to something like passive house, and how would you encourage a developer? We're doing built green 4-star on our smaller projects, and which is obviously fairly easy to achieve, but to go to this next step, there's always been there's always the concern of cost and versus return, and how would you guys kind of advise somebody like me who wants to go to this next step in terms of the benefits of this?
I
take it from the developer side.
Mark, I'm sure you got some ideas too.
Yeah, well, we just presented this at NAOP as well, essentially, why we should encourage development of these types of buildings. And not necessarily that every building needs to be passive house certified, because passive house, as Sloan mentioned, really only looks at the energy portion of the building, how much energy it uses. Whereas, LEED looks at a lot more things, from energy to materials used, recycling, etc. And then Emily has other ones that she is close to, like well certification. So there's a lot of them. So I think the basic benefits, though, are, I've always just used this one mathematical formula. So if you just use math and nothing else, forget about the fact that the climate's, going to hell in a handbasket and all that. Okay. Buildings are built on, they're valued based on a cap rate off the NOI.
Right.
So let's just call it a building is worth 20x its NOI in general. So if I can increase the NOI by $1,000 and it costs me anything less than $20,000, in theory,
Mm-hmm.
you should do it. This building, as an example, uses significantly less energy. We show 50%. I think it's going to be a lot lower. Our last electric bill with a 60% occupied building was $605 for the entire building in the hottest month of the year.
Yeah.
So, we're talking $12 a unit or something. It's really, really low. And so now you have to figure out how to capture that, right? Because that's something that normally goes just to tenants. So you have to figure that part out. But in general, not only doing something good for the planet if you can reduce your energy usage, but you are in theory increasing the NOI of the building. And that will have an immediate payoff if you sell the building, and it will have a long-term payoff if you hold the building. So those are the easy reasons to do it.
Mark, if I could interject, I don't know that we've mentioned the cost premium on this building to meet Passive House.
Oh yeah. So it's 5% or so.
Yeah.
The interesting thing though is that, the code is changing. So 4-star Build Green is essentially going to be requiring ERVs, right? In the near future. And I know there's a lot of pushback because it does increase the cost.
Right.
And also, I think one of the more interesting things is that I've now done energy modeling on several buildings that we've built. ERVs are not the best bang for the buck. So that's a little bit unfortunate because from an energy perspective. They're a huge bang for the buck from a health perspective. So we focus a lot on, if you go look at our building, I think one of the things it says is our air is better, right? That's like our slogan almost for the building. So
actually, this
people are health conscious right now too.
Yeah,
more than they were.
Sorry, so is there fresh air for these units or?
Yeah, so these are all non-trickle vent.
Okay.
So the building has, 80, and our results show 88% less air leakage than a typical building. So, and we did that with Prosecco liquid wrap and these triple pane windows that are obviously really well sealed around the edges, and no trickle vents.
Aaron, pause on that slide, would you, if you can?
Oh yeah.
We had it on auto. It was a shot of the mechanical system. I thought.
Yeah, so we have one ERV per floor. That's the ERV per floor, and it branches out. All the ductwork goes to each of the units, and then it goes straight to the roof. So that's a huge difference on this building too. There are no penetrations on any of the walls of the exterior walls. Zero, right? Normally you're going to have 2 per unit. Yeah. One for the bath, one for the hood. And then you have a whole bunch of trickle vents that are kind of built into the windows. Completely different methodology, right? Everything, it's all mechanical venting unless you open a window.
So the ERVs provide a continuous flow of fresh and filtered air to each unit. And I'd love to find our slide related to air quality, because especially now as the sky is dim with fire smoke, we have the air quality, because the air is so filtered and the building is so very airtight, the air quality inside is very, very good right now.
What about the just general comfort and ventilation in a hot summer day?
It's way better. I mean, but these units all have heat pumps. So, yeah.
But also
even when, that's the thing, 40% of the units are not occupied. And they don't have the AC turned on. Well, some of them do, and because no one's going into them. But on the 90-degree days, it was significantly cooler. Yeah. In the building, in units that did not have their heat pumps turned on.
What does the new code change kind of do for Passive House in general? Is it going to? You think it's going to encourage more people to do this, or?
The code change is just going to require balanced ventilation. So that's going to be, and that starts in February. And that'll be a very big change for most people who are not doing something like this. Right. For people who are doing Passive House, it doesn't change anything, because just doing balanced ventilation, as Mark said, the ERV, the impact of that is not necessarily a cost helpful on the pro forma side. However, if you use efficient enough ERVs, it does actually move the needle quite a bit. But I think people who are just dipping their toes in balanced ventilation are going to just try and find the cheapest equipment and just try to meet the minimum standard. So that would be a different approach than passive house. It's still definitely moving things in the right direction. Myself having lived in a passive house for a number of years now, I can attest to the advantages and benefits of having balanced ventilation and having a very efficient ERV and all those things. But until you've experienced it, it's a little hard to really kind of wrap your head around it.
Yeah.
Yeah, Sloan's actually 80 years old, and just look at him.
Yeah.
The other difference is it's not totally fair to say that a lot of people say that the code is going to passive house, but it's not entirely true. The code is going to require ERVs and additional more stringent energy measures, but the air sealing requirements for passive house are still a mere fraction of what code is. Code allows 0.2, 0.4 right now. It's going to 0.3. You can do an enhanced air barrier for 0.25 CFM per square feet of envelope area. But passive house for multifamily is currently 0.06. So it is still so much tighter than a conventional building. And that allows the ERVs to be very small, and it allows the heat pumps to be very small, and that allows the whole mechanical system to be extremely efficient, which does save energy. And also, passive house is getting more stringent. This was the first certification from FIAS, the Passive House Institute US, that we were under for Solis. But they have already released their 2018 standard that I think if you were to construct now, you'd be under. And the threshold has gotten harder as well. So.
And that's one of the other interesting things is when you have such a tight thermal envelope and so much insulation, any type of heating or cooling system is essentially overkill.
Yeah.
Right. And we have a slide here that shows a toaster, and they said that's, you can heat an entire house with a toaster. Well, now you've got, a 1 ton, 1.5 ton, or 2 ton unit, depending on your line set lengths. And so you can just turn on your AC for, 3 minutes and your whole place is done. And then it goes off.
Wow.
Right. So, you're severely underutilizing any type of heating and cooling system, which is unfortunate because people don't make smaller ones yet.
They're starting to now. They're starting to come out with smaller ones, but they need to come out with even still smaller ones that are be appropriate for. It's interesting because for houses, they've kind of realized, okay, efficient houses need smaller systems. So we've got some of those, but to serve a 600 square foot apartment unit efficiently is still a challenge. They don't really have equipment small enough for units that are passive house. The loads are just so small.
We need someone to come up with where you just kind of like press a button on your refrigerator and it shoots some cold air out. That would be enough potentially. Right? That's awesome. All right, there's the next business idea for anyone listening. It seems like we actually do have some more people here.
Something else worth mentioning is that while the difference between maybe passive house and code is getting smaller and smaller, the other thing that we're seeing at Weber Thompson on sort of more large scale buildings is that the market is requiring air conditioning more and more. Mm-hmm. And once you're already providing air conditioning in the form of either heat pumps or the VRF system, you're getting really close. So between the ERV, the mechanical system is so much of the cost that the cost delta is shrinking because of the market demand for air conditioning.
It's a really good point. I absolutely agree with that.
What size projects do you work on, Scott?
They're all about 30 to 60,000 square feet. So this scale and smaller, I'd say, and yeah, we're starting a lot of these right now this quarter. But yeah, I mean, some of these we're getting more advanced.
Scott, you're with Kamiak, right? Is that right?
That's right. Yeah.
Okay.
That's right. So, yeah, this is really helpful. I met Sloan for coffee a couple of years ago, and he gave me a little bit of a 101 on this, which was great, but I just haven't taken the leap into it yet. So,
yeah, I think the tough part is, especially want to provide ERVs or air conditioning, it's pretty difficult to add that later. You know, it really needs to be in the original design because you just don't have enough space for it. The ventilation, you know, everything, right? You need to have at least
we're
6
usually doing the
vertical
top
stacks.
2 floors, the top floor of the top 2 floors now, but I really want to do it for the entire building. So now we're getting closer to having a project where we do have air conditioning for the entire building, which it's interesting to hear that it gets you that much closer to the certification. On I guess from there it's really just fresh air and then insulation. You're probably there.
Well, so
Yeah, Emily made it test. It takes a bit more than that.
I didn't mean
especially
to
under this code.
oversimplify. If I could share one of the big, I think, epiphanies of the project, though, is that the amount of insulation in Seattle in multifamily for Passive House is actually, it is more than typical, or it is more than conventional. But it's a big realization was that it's not as much as you may have thought. Oh, I see Aaron's slide hovering. One up from there, if you would, Aaron, I think.
Is this the one?
This was our, Sloan can probably also speak to this because he's so much experience with SIPs, but this was our wall assembly evolution, where on the left-hand side, that's the wall assembly that we started with. And I think a lot of people would associate this kind of wall assembly with a passive house or a really energy efficient building. And this is required if you're doing a small scale, single family kind of building with a lot of envelope to occupied area. But we were actually first able to make the energy model pencil using 2x6 or 6-inch SIP panels. And then when even that came back, we had a hard time getting bids on that for the multifamily market. We ended up going with stud frame, 2x6 and 2x8, and some 2x10, but mostly 2x6 and 2x8 exterior walls with high density insulation. And that is, I mean, typical. I'm sure you use the detail on the right all the time. This is what so many multifamilies of this type of project use in our area. And we were able to get the energy model to pencil. And there's some other unusual details where we really had to track our thermal bridging at the podium and at the roof. But I think it was a huge aha moment that we got the vast majority of the envelope to pencil with a fairly conventional thermal envelope.
Interesting.
But that was there's 2 big caveats to that. The first one is that we took a huge chunk of the building out of the passive house envelope. All the retail, and so everything below the podium, and 2 pieces of the exterior, 2 pieces of the circulation, which are the main stairwell and the elevator shaft, right? So that's highly unusual. The second thing is that I don't think we'd meet the new code with this assembly because it is so difficult to meet now.
Yeah, that's true, Mark. We would probably need to have 2x8 exterior walls to meet the new passive house requirements. I've got another project that we're about to start, which will have entirely 2x8 exterior walls. So that's true.
But Sloan, are you talking about the passive house requirements, or are you talking about the energy code requirements?
Passive house requirements.
Yeah. Mark, if you were talking about the energy code requirements, I think that
no, I was talking about passive house.
Oh, you were?
Yeah, to meet code, no. To meet code, it's easy.
You guys are on the same page.
To meet code is easy. Not that easy, but it's getting harder.
I'm positive we would have made the new energy code.
For sure. I was just saying, this building under the 2018 passive house probably wouldn't make it because that code is so stringent, even though we implemented so many measures.
Yeah, that is true. Hey, I just wanted to welcome, there are a few other people in the room, wanted to welcome them. No pressure to turn your cameras on, but if you want to join a conversation, we're just keeping it pretty casual here on a Saturday morning.
If we should show some photos of the project so new people can see them.
Keep browsing, yeah. Thank you, Aaron, for managing the slide.
This is our rooftop. a portion of the rooftop. The rooftop, you know, I think one of the interesting things about this project, and it was not intended to be this way, but if you look at the rooftop as an example, you have 4 distinct areas where people can gather, all socially distanced. So that's, you know, we got lucky with that, I think, to some degree compared to most. And the whole building is essentially like that, where all the common areas are actually outdoors, including the lobby, and the building has no shared air between spaces. All the air is filtered. It all comes from the roof. So you've got this, you know, a significantly healthier building from a virus, you know, contagion standpoint, which we certainly did not plan for. Wish it was not an issue right now. But that's one of the benefits of doing Passive House also, is that your air quality is not only better, but it's not shared, right? Units don't share any air.
That's right. There's air sealing between the units, which is actually tested for in Passive House. We have to meet a certain threshold. So that's, you know, odors from your neighbors who are cooking or whatever they're doing is not an issue in this type of construction. So it's just a little more attention to detail.
But there are interesting issues that do arise, which I think is worth bringing up. So if you just do a standard Passive House, you've got, so first of all, there's no natural gas cooking. So cooking, there's a couple differences, and this is a great slide to stop on. So you're all electric or induction for your cooking, because natural gas, amazingly, degrades the air quality so fast that, and this is maybe a note for everyone on the call, you should always turn your hood on before you light your natural gas. And if you had an air quality monitor next to your stove, you would watch it so quickly degrade, both volatile compounds as well as PM 2.5s, to get technical on it. And so we wanted to put natural gas in, not knowing anything about Passive House when we started this, and quickly realized that's a no-go. The second thing is, you don't have a typical hood. It's a recirculating hood. And you can't see it, but in the ceiling above that, there's actually a return duct that goes straight to the roof of the building. So we're constantly filtering air out, but you don't have that you know, really high CFM hood that you can turn on when, say, you're cooking fish or something like that. So you're relying on the building's main mechanical system to take care of all those smells, which is one of the other reasons it's important to seal units, seal in between units.
We have a question from the audience. Helen writes in, what is the Passive House threshold for in-between units? And I don't know off the top of my head. Is it an actual threshold, or is it just a list of criteria that you have to meet?
No, it's an actual threshold. There is an air tightness number. I don't know what the number is. I'm not at that level of technical specificity. But there is a test, and you have to isolate other adjacent units, and then you air test between units. And I don't know what the number is, unfortunately. But yes, there is a number, and it is tested. And they sort of do a random selection of units. You know, do this unit, that unit, that unit, and if they pass, then we presume that all the units are that tight.
I will try to look that up for you, Helen, since we are having the resources in front of us. I'll just pull up our air barrier test, but you guys keep talking, and if I find the answer, I can share.
And Helen, thank you for using the chat. For anybody else who's feeling camera shy this morning, feel free, if you have questions, to use the chat feature. I'm assuming we're all pretty comfortable with Zoom at this point, but if anyone has Zoom questions, let us know, and we can help you navigate the tools that are available this morning.
Can I ask you where you got the windows, or what the manufacturer is of the windows?
Either Eurotech.
Oh, okay.
Out of LA.
Yeah.
Really great. Just a quick note on them. Really great performance. Generally good quality. We've had a few issues with some of the windows and a few issues with operational sides. Some broken windows that happened, some fingerprints on the inside, things like that.
Yeah.
And those, so I haven't found a perfect window company. You know, you take a VPI or something like that, and operationally they're amazing. Quality of their windows is far inferior to this, though.
And this is the Poland company? Polish
No,
company?
it's not.
No, that's
Polish.
what's that one called?
Oh, there are many. Zola is a Polish. It's the same idea.
Okay.
It's the same profile. What's cool about this company,
Drew,
Scott,
you're thinking
is
of Drutex.
they're yeah, Drutex. What's cool about this company is they're in the U.S. and they're on the West Coast. So, oh, we broke 3 windows. Okay, throw them on a truck. They're here next week.
Great.
It's very different than importing and waiting 12 weeks for it to come across in a container. That's a big
Although
difference.
I think Drutex they're supposed to be getting manufacturing in Reno. I'm not sure if that's happened yet or going to happen. But I've been to a few Drutex projects as well. I just think it's interesting, and the quality really is kind of all over the place to some degree. Like, we did have problems with our swing doors, which are just on essentially the south side of the building, getting them to be perfectly aligned and sealed. Eventually we got them and they're working great now, but there can be a little bit more brain damage to get these larger triple pane windows from smaller manufacturers.
Scott, they are tilt turn windows.
Yep.
Yeah.
That's great. Actually, I think we're using Eurotech on our project that's starting this month. I know we are, but I thought our contractor said they're out of Poland, but maybe it's not the same company. Anyway.
So Helen had a question about reviewing the wall assemblies again, because she joined kind of midway through that conversation. So do y'all mind just kind of going through that one more time?
Sure.
Emily.
Oh yeah. One of the big realizations on this project was in Seattle, where we have a more mild climate, and with multifamily construction, where we have a pretty huge occupied floor area to thermal envelope ratio. Small ratio, excuse me. Just that, unlike a single family house that has unconditioned conditioned walls on all sides, a tiny little urban unit is going to have 3 shared walls and then 1 exterior wall, which helps us out tremendously from an energy standpoint and in meeting the passive house requirements. So where we thought the wall assembly would need to be on this project is the detail on the far left hand here that shows a super thick stud, maybe even a truss kind of stud with blown in insulation, and then rock wool exterior insulation on the outside. Lots of passive houses in this area use this detail. We ended up going to a SIP panel, which Sloan's had great experience with, just a 6-inch SIP panel that performs great from an energy standpoint because there's no thermal bridging. It's very consistent from an insulation standpoint. But when the bids for that came back too high, because contractors not being in, Sloan could probably tell us more, but as I understand it, not a lot of SIP subcontractors were interested in working at this scale. Is that right, Sloan?
Yeah.
Yeah. Then we ended up going to stick framing, which is just 2x6 and 2x8 studs with high density fiberglass insulation and no exterior insulation. And that's just Weber Thompson. We had no idea that we could get passive house level energy performance with such a conventional multifamily kind of envelope or wall assembly. And the next slide, actually, Erin, shows the extent of where we have different stud sizes. You can see where we have the 2x8s and the 2x6s, and it looks like we have some 2x12s too. But we do have more insulation on the podium, which is the bottom of our passive house envelope, and on our roof. But from a wall standpoint, we were able to do quite well with not a whole lot of added insulation.
Emily, can I ask a dumb question for anybody who doesn't know? What is a SIP panel?
Oh, a structurally insulated panel is a panel that has 2 pieces of plywood with rigid insulation in the middle. And it is a structural panel, so you don't need studs that act as little thermal bridges. It's homogeneous. So from an energy standpoint, it works really nice.
Cool, thanks.
Can I also ask the team, Are there any incentives you get at the city besides, I imagine you get priority green? Any other incentives you get?
Did we even get that? And does
Yeah, I
that
know.
actually matter?
We actually did, Mark. We actually did.
It was so far, it was so long ago that, you know, the project got permitted and then there was a pretty big gap before it got, before groundbreaking occurred. So,
Yeah.
The
but
short
other than
answer
that,
is,
no,
yeah,
Well,
we
there have
weren't
not been
able to
any
take advantage.
financial incentives.
there's a
Oh,
there is a
yeah.
there are a couple city light programs. There's one called Built Smart,
Yeah.
which writes a check. Scott, I imagine you're familiar with that.
Yeah.
There's also another brand new program that's so far only been done on the Bullitt Center, and they've been using it for 5 or 6 years, and it's a little bit of a wonky program, so I'm not going to get too much into it, but it talks to, Mark, what you were mentioning earlier about the split incentive, where the developer invests in the building upgrades, and then the tenant gets a cheaper utility bill.
That's right.
So there is a workaround for that, and we're going to be participating in that. They're now opening it up to more buildings. So that solves for that problem, Mark, and brings the savings back into your down to your bottom line.
Right.
So
It's interesting.
Yeah.
It does provide a little bit of this, I forget what, but basically where if a tenant is moving into a building, assuming their utility bill is going to be significantly lower, and that's one of the reasons they move there, it does take some of that away. So it's kind of we'll call it cognitive dissonance was the word I was thinking of. So if I'm like, hey, I'm moving into a passive house building and I actually know what that means, but my bill is the same as if I lived in a, standard building, then that's been my concern with that program. I think probably 90% of people won't even notice or care, but there might be
Mark,
10% that say, hey.
How many of your tenants do you think are aware of passive house when they move in?
They're all aware by the time they move in, because it's when we walk them through the building, we certainly talk about it.
Yeah.
And also, I think on top of that, because Seattle City Light is so far behind with installing unit meters, everyone's on a house meter right now. And so we are accruing a very small balance for all their electricity. And we're saying, guys, it's $20 a month. And we think that's going to be way more than, we're going to actually give you a refund. And so people are like, whoa, that sounds great. Such a small amount. And the actuals are coming in, I think, as I mentioned, around $12 a unit. So it's certainly lower than our other projects.
There's also a program called the Seattle Building. Oh boy, it's called it's the 2030. Is it the Living Building Pilot Program? No, never mind. It's morning and I haven't had my coffee yet. I'll find the name of the program, but there are it's in the code, in the zoning code, where you can get extra developer incentive in those zones, and it requires a green building standard. That is what I am talking about, the Seattle Green Building Standard. Sorry, guys. They have listed passive house as a way of meeting the green building standard. They have also listed LEED, so it will be but LEED is getting more stringent. So passive house is a way.
So is passive house. But that's one of the nice note about passive house. So it does meet the HUD standards for green. Right, and the HUD standards for green, which gives you a lower rate on your permanent financing if you choose to go that route, have become much more stringent, right? Or they're becoming much more stringent. Does this project have a publicly sorry, Aaron can read that maybe.
Yeah, I can be the moderator. Helen wants to know, does the project have a publicly visible utility usage for tenants as an additional component, educational component for residents?
It does not, but we have been considering it. The problem is that I don't know how to get electrical usage. So we can show publicly water usage because we're sub-metering, but electrical is not sub-metered, it's direct metered. And so there's a privacy issue with that we haven't figured out a way to overcome. I would love to be able to gamify to some degree, use less energy, right? And that'd be fantastic, but I haven't found a way to do that with electrical today in a multifamily building. In theory, it could be done in a hotel because you can sub-meter, and potentially, I think in a commercial building, you can do it because you can sub-meter, but not in a multifamily building that I'm aware. Sloan may have some ideas on that.
Yeah, there are ways to do that. Have you seen the Green Fire campus over in Ballard, Mark?
I've seen
It's
pictures of it. Haven't
it's
been there.
really cool, and they have that system that Helen asked about. There's like a dashboard, and you walk in and it shows yesterday's energy consumption, and yes, and it can be done. I think you
So
have to.
okay. So they're sub-metering, but then they're probably doing it anonymously.
Yeah, you can do it non-anonymously. There's some paperwork involved, and there's some cost, and I think that's where a project of this scale, you kind of run into those issues like how much money are we going to dedicate to this system?
Mm-hmm.
We had done a competition entry a few years ago for a student campus down in California where we had come up with a gamification system for energy usage for each unit. And it was actually displayed with an LED band outside the unit that would change color based on the tier that they had hit the previous month.
That's called public shaming.
It didn't actually happen. So there probably would be challenges with privacy and all that, but it's a great concept, to try to encourage residents to, it's like public shaming kind of, right? And it could work to help drive down energy usage.
Yeah,
we could probably work on in student housing if as long as there's just one energy bill. Yeah. Go ahead.
We built in energy bill disclosure into our lease on another passive house building we have. So the tenants have all agreed to share their energy consumption.
That's great.
There you go.
Yep.
Cool. Well, we've had a few new people join. We are down in the weeds, certainly on the project right now, which is amazing. But I just wanted to see if, let's see, Sabina, Steve, Stephanie, Maggie, and Rushian, if you have any questions or you want kind of a basic introduction, feel free to turn on your video and ask a question or use the chat feature. And Helen has got lots of questions this morning. So she says, Sloan, is that through EPA Portfolio Manager?
Good question. Portfolio Manager is one of the ways which we get whole building data. We can also get individual unit data from the utility as well. I don't know all the details.
There's lots of brands of sub-meters that you can put. You could even put Sense energy monitors on every unit now. They've got a multifamily offering that integrates with a few unit automation companies. So, and that actually would show you by device how much electricity is being used throughout the entire building. So I think there's lots of sub-metering options and monitoring options. Water is something that's been done for, decades within buildings.
So since we have a couple new folks, maybe we should just do a basic kind of rundown of the building again. Steve wanted to know how many units the building is. So maybe Mark, if you want to just give the basic overview intro, and then we can go from there.
Okay. So Solis is a 45 unit apartment building. It's on 13th and Pike. So we're kind of right in the middle of Capitol Hill, just outside where the former CHOP was. And it's got 3 retailers on the bottom. It's received its certificate of occupancy just a couple weeks ago, and it's leasing up and people are moving in. It's also got a company called Sonder operating essentially kind of more of a longer term stay, extended stay hotel on the 3rd floor. It's currently the largest certified passive house multifamily building in Washington, and probably a much bigger area than that, to be honest. I'm assuming that will not last very long. I think Sloan's already working on one that's bigger. So it's got a pretty amazing rooftop kind of garden space, and some of the highlights of the project are it's truly built to condo spec. In fact, it was going to be condominiums for sale. It has air conditioning, which was one of the ways we got to passive house certification, was using individual heat pumps for every unit. And it's got significantly better air than your average building for 2 reasons. Number one is that it has an envelope that is sealed and has about 88% less air leakage than a new code building. And it's got this energy recovery ventilation. Aaron is just nailing these slides, transitions, oh my God, which essentially pull fresh air from the roof, bring it into your unit, and filter it, bring it into your unit, and then take all your stale air and shoot it out the roof in a different location. And so that dramatically improves the air quality. It also eliminates any shared air between units, because units are both have their own ventilation system to the roof, as well as they're sealed from each other and from the outside. So that's kind of quick overview of it. And if anyone has any questions on the project, it's got about a 70-foot mural on the north side of the building. I wonder if we can show a photo of that. Aaron's searching.
Give me a minute. I'm working on it. Here we go. There's one.
There you go. This is from a pretty famous artist out of the UK who came over, and he's been a friend of Solterra's for a while. And this is the second mural he's done. We have another one that overlooks Portland's downtown. That's gotten been on many magazine covers at this point. This one has yet to grace the cover of a magazine. We'll work on that.
Young. It's young.
So we could show a video. It'll take me just a minute to open it up. The latest cut was wrapped up last night, and I haven't actually seen it yet. So we can have the premiere right now.
Ooh,
with
wow.
all of us. So I'm going to stop
Exciting.
sharing for just a minute so I can find it. And then we could watch it, which would be pretty exciting.
There hasn't been an actual movie premiere for 6 months now.
I know. I know.
Until this morning.
Until right now.
Okay, can you guys see that?
Yes.
Okay. Here we go. Can you hear, is the volume okay?
Welcome. Thank you for joining us for this virtual tour of Solis. As of May 2020, this mixed-use apartment building in Seattle is the largest certified Passive House project in Washington State. Solis is brought to you by Solterra, one of the region's greenest developers, Cascade Built, the city's most experienced builder of Passive House projects, and Weber Thompson, a multidisciplinary design firm adept at providing market-based solutions. Weber Thompson was the architect, landscape architect, and interior designer for this building. Solis is one of the healthiest buildings on the market and achieves dramatic reductions in energy use. Using 50% less energy than the US multifamily median, it scores a perfect Energy Star 100. Using simple design strategies and conventional materials in innovative ways, these feats were accomplished for a mere 5% construction cost premium. Lush landscaping, natural materials, indoor-outdoor spaces, and thoughtful details make Solis the pinnacle of eco-luxury living. Solis is located in the Pike Pine corridor of Capitol Hill, a dense urban neighborhood in Seattle, best known for its arts culture, restaurants, nightlife, and LGBTQ+ community. A driving factor in design was connecting the architecture to the culture and identity of the neighborhood. A vibrant mural on the party wall titled Amaterasu, the Japanese sun goddess, grounds the building in the neighborhood's flourishing art scene. A striking patterned screen jewel box completes the feature corner of the block with a boutique restaurant while also creating a one-of-a-kind residential entry gate. The commercial spaces welcome pedestrian street traffic with tall wood storefront windows and daylit interiors. Retail canopies with integrated solar panels offer weather protection and dappled sidewalk shade while hinting at the building's energy-conscious design. Above the ground floor, there are 5 stories containing 45 apartment units with a mix of studio, 1-bedroom, and 2-bedroom apartments. There's 1 level of below-grade parking. An expansive roof deck provides resident gathering space around an 80-year-old Japanese maple and offers panoramic views of the Seattle skyline and Mount Rainier. The residential levels are certified by Passive House Institute US, or FIUS, under the FIUS Plus 2015 requirements. Passive House buildings must meet an energy performance target, and building science principles provide the roadmap to success.
At Solis, we incorporated a set of coordinated design strategies that result in lower energy use with minimal additional investment. These primary strategies are a continuous air barrier, a continuous thermal envelope, and a balanced ventilation system. Perhaps the most important, the air barrier needs to be continuous and airtight. This ensures the energy put into the building for our comfort stays inside the building. Clear detailing by the design team and attentive execution by the construction team resulted in an air barrier field tested to a level of performance 5 times more effective than code minimum. We then paired this enhanced building envelope with a balanced, high-efficiency ventilation system and HVAC system to create the healthiest and most comfortable indoor air environment.
Passive House principles are present in every aspect of this building's design.
The purposefully simple building form minimizes transitions and corners. These can compromise the continuous thermal envelope and continuous air barrier that are so critical to successful energy performance. The residential lobby, central staircase, and even the elevator were moved to the exterior of the building. This reduces the amount of energy required for space conditioning. The central staircase was also a prominent design feature. Its warm wood cladding, accent lighting, and gracious landings connect residents to the outdoors and provide casual social opportunities. It also encourages folks to take the stairs instead of the elevator, enjoying some exercise and saving energy. Mechanical shafts and rain leader downspouts, which often penetrate the envelope in conventional construction, are run on the exterior of the building to reduce wall penetrations, making it easier to maintain an airtight envelope. When penetrations were required, they were grouped together, carefully sealed, inspected, and tested to ensure that they were airtight.
Here we are at the lungs of the building, the energy recovery ventilators, or as we know them, the ERVs. The ERVs provide a continuous supply of fresh, filtered air to the building residents. This promotes health by filtering out pollen, dust, mold, and bacteria, including outdoor pollutants like wildfire smoke and diesel fumes. In fact, numerous studies have connected ERV ventilation to boosted cognitive function, and with the right filter, you can even remove harmful viruses.
While Solis's energy-saving measures are good for the planet, it distinguishes itself in the marketplace by providing residents with a luxury eco-living experience unlike any other, with a focus on physical wellness and connection to nature. Natural and living materials and incredible daylighting are a result of biophilic design principles. Tall ceilings and gracious European-style windows flood the units with natural light and contain large operable panes for outside air. Triple pane glazing creates an exceptionally quiet interior away from the bustle of the outside urban environment. Resident balconies and terraces provide private outdoor access and contain lushly planted stormwater filtration planters that help reduce urban runoff. Healthy finish materials were selected to meet the EPA's AirPlus standard, and matte surfaces are used to reduce glare. The energy-efficient systems mean that residents pay less in heating and cooling bills. Thanks to ambitious project goals from the outset, Solis is now Washington State's largest Passive House certified building. It delivers dramatic reductions in energy use and exceptionally comfortable and healthy spaces within the cost range of market-rate multifamily construction. We share this information in the aspiration that Solis be a model for what all new multifamily development can achieve.
Ta-da! That was great.
Thanks, Sabina.
That was awesome. I love seeing that.
Yeah, y'all saw the premiere. Congrats.
I need, please send me that so I can share it with people.
We will, definitely. We'll be posting it online and making it available. We'll add closed captioning and stuff like that too. So once it's ready for public consumption, we'll share it with everyone.
I really like the tilt-turn windows, the European style windows. How did you, is that just something that the manufacturer offers? Like, is that all they offer, or how come it's not the traditional, sliding glass window or awning window?
Totally. The reason is because to meet the air sealing requirements of Passive House, we had to get a window that was certified that was tight enough for Passive House air sealing requirements, and maybe Sloan could weigh in. I'm not aware of all the manufacturers out there that can meet those requirements, but almost the vast majority of them are tilt and turn because they truly get you that super tight seal. Is that true?
Yes, that's true.
I think they all are.
They
They're
all
also
are.
tilt and turn.
Tilt and turn. I know you can't do a slider, but
they have multiple points where the hardware brings the window closer and seals it completely. In fact, it's got happened to be sitting here, so maybe I can just show you how one of these works. So, somebody swing it this way.
Oh, look at that!
live demo.
You're
right
just ready
there.
for that.
This is a live tour, folks. So there's points in the window where there's hardware that seals here, and here. So you've got multi-point locking. So the portions of the window are able to seal it completely, and there's gaskets both here and also back in here. So I don't know if you could really see that, but essentially there's multiple.
And the important note there too is that you've got that steel reinforcement, which keeps it really rigid.
Yeah.
So that even when there's 4 points on a plane, you can push it against a weather stripping and seal it much better than a typical.
It completely seals the window really tight. So this creates 2 points of seal all the way around the window, which makes it airtight, makes it watertight. And sliding windows, if you ever notice like a typical slider in a typical American house, you can actually, there's enough space in there where you can actually pick the window up, tilt it in, and remove it, for maintenance and things.
Yeah.
And so that gap always exists. There's, like a centimeter all the way around, and air comes in, water comes in, spiders come in, all the things that want to come in, fire, smoke leaks in. So it's kind of a different approach. And you can't get a slider, doesn't work in Passive House. They're just way too leaky.
Okay. Interesting. Well, I'm glad that we finally get to see European style windows over the pond, on this side of the pond.
Yeah, and these are actually made in California. So finally they're making them here too, which is great.
Yeah.
These windows were imported from a long way away.
Back in the day.
Back in the day.
Yeah.
Carbon footprint a little higher on those, but they make up for it.
Yeah.
So another compliment that I want to give you all is the external staircase, the quality of light that all the imagery, provides. Is that it's just a really nice place to be. Seems that way.
Yeah, so one thing I know we've talked about, the video talks about this, but we are really proud of this building and the fact that it was built at a 5% cost premium. And the client actually, he'll say, he'll be on shortly, but he says actually it probably could have been done at about the same price as market rate multifamily buildings, but because we had such a commitment to creating a beautiful building and integrating artwork, the custom mural and other things like that, that's probably largely what contributed to the cost premium. So we really do think that this can be done, and that all multifamily buildings should be Passive House. There's no excuse really for them not to be. So we're evangelists for this kind of construction for sure.
And that's a 5% cost premium over a conventional Seattle construction. But it's also worth mentioning that more and more the energy code is pushing us closer to Passive House, and also more and more the market is pushing us closer to Passive House, not necessarily because people are interested in living in a Passive House building, but I know at Weber Thompson, more and more of our projects are going with air conditioning and going with the high efficiency air conditioned heat pump units that provide air conditioning and heat. That was so much of that premium cost that the gap is getting smaller every day. A question, thank you, Pat. Could you explain the large vent on the exterior? Is that exhaust air going back to the ERV? And if so, how does that save energy? That's a great question. Erin, you're on it. So that's not, the ERV is on the roof, and I think we have a good roof shot deck that shows the well, there's our heat pump farm. So I take that back. The ERV, there's one ERV on each level, and that's ducted up to the roof. And then on the roof, there are two big ducts, one where the outputs are far away from each other. One's for supply and one's for exhaust. So that's how the ERV is getting its fresh air in and out of the building. The ducts that you see on the exterior of the building are actually the transformer room exhaust. The transformer is located on level 1 in the concrete portion of the building, and we didn't want to penetrate the podium of our passive house enclosure. So we ran it, and we were unable to vent it, unfortunately, out to the street, which is what would be the most cost-effective way. But it's such a tight urban site that that wasn't possible. So we brought it up to the roof, and we built a 3-hour rated non-combustible shaft on the exterior of the building. So that's the white shaft. And then the gray shaft on the right, thank you, Vanna, is the garage exhaust. And for the same reasons, not wanting to penetrate the passive house envelope, we ran it on the outside. And then the other thing that you can see here is the rain leaders. Those come right off the roof and go straight down the building. Because they don't go through the roof insulation, they also don't penetrate the passive house envelope. And it's pretty slick, but they feed into a large stormwater planner on that level 2 podium. So we are filtering rainwater at the same time, which is not a passive house requirement, but is a City of Seattle requirement and a do-good thing to do.
We can run through just some more eye candy if we want to.
I love the eye candy.
The other thing we could do, we haven't done any of the Matterport tours, but we could do that. And that'll take just a minute to share if folks would like that. Basically, we can kind of give you a little bit of a 3-dimensional tour through certain spaces of the building. So I'll just have to pull that open here.
While you look, I mean, I'm curious to know what the expertise in the room is, why people are attending the Green Home Tour, designers or developers or residents, or what kind of projects are you familiar? If anyone feels so brave as to say anything, I'd love to know you guys.
Emily, this is Chris Van Dalen. Thank you for that invitation. I'll take you up on it.
Hey, yeah, thank you, Chris, for nibbling.
Yeah. Hey, Pat, and I don't think I know others here, but I see Pat Park on here. That's a good friend of mine. Anyway, I was going to mention that this project is really an example of what we started a statewide alliance about, which is the Shift Zero Alliance, a zero carbon building alliance. And we're looking to really, as an alliance of 35 plus organizations, all with different approaches to sustainability in the built environment. But the one thing that brings us all together is, alarm about the climate crisis and the need to scale up in an equitable way for everyone, the ability for everyone to live in a healthy, energy efficient home that they can, that contributes to the climate solution. So this building is exemplary because it uses the passive house standard to first and foremost minimize energy use in the building. That's like the first thing you got to do if you want to eliminate carbon emissions from your building. Also, you've got an all electric appliances in here, which means no combustion of fossil fuels within the building. And then finally, you've
you know, I don't know if I guess there's no solar on this building, so there's probably is some energy load. So I guess it would technically be a zero carbon ready building. With the addition of solar, you could get close to a zero carbon building. Are you guys doing any offsite renewable energy credits to offset the remaining energy use?
We're not. These are such great points. Thank you for plugging Shift Zero. Chris, you probably don't know that we're related, but my husband is Andrew Lee, who is the new incoming co-chair of that organization. This project does have some solar, but it was more used in a decorative way, I will say. It's on the canopies at the grade level. We just wanted to celebrate that it was a sustainable building and give people kind of we wanted a marker to show people that it was very energy efficient. But realistically, they do very little for energy production. And then the rooftop is solar panel ready. Solterra, the developer, it's a company with two arms. One arm is the development company. The other arm, the more the older arm, is actually a solar panel company, solar panel installation company. So of course, Aaron has cropped this image of the roof deck to just show the occupied roof. The other half, real-time photo editing? No.
You know, I was like, maybe I can take you if you hang on here. You'll just get
it's all good. Imagine, if you will, the whole other side of that is our little heat pump farm, the ERV ducts, and then an area reserved for future solar panel ready. But the other point I wanted to share was the dirty little secret of this building. It was designed to be all electric, and it had some serious financial problems back in 2017. And at that time, through VE, we got rid of our reverse cycle chiller in the garage that was our domestic hot water boiler. And so this building now has a gas boiler. Okay. So we are not a zero carbon building. But
good effort anyway.
Thanks. It's interesting though that from a passive house standpoint, it was actually passive house, and you probably know this, has these somewhat obscure formulas that you use to meet your energy targets. And one of those gives you you're not using site energy, you're using source energy to meet your energy targets, and then it gives you the transmission loss values that you need to use. And so for that reason, because the transmission loss of gas is actually pretty low compared to electricity, our energy model penciled just fine with the boiler swap. And that's sort of a heartbreaking example of, despite the best of intentions, how a certification system can incentivize against what it stands for, if you know what I mean. And this is not a statement against Passive House, and I think they're working to fix this, but it's maybe something to be aware of for other people here who are doing Passive House projects.
Interesting. Yeah, it's good. I'm sure that they are probably pretty intent on trying to fix that. You know, sometimes there's unintended consequences that you can't anticipate in the way you design your system. So
completely the case. And this was the first, FIAS, the Passive House Institute US, has this new North American certification system, and it was new as of 2015, and this project is using that system. So this was the first, that was the first US certification for Passive House, and I'm sure they're tweaking it.
Gotcha.
So this is a 2-bedroom unit that I just pulled open the 3D tour of. So the building has studios, 1 bedrooms, and 2 bedrooms. Is that correct? Open
Correct.
One as well. Okay.
Here's an interesting story just from an interesting part about this project was because we used a number of products that weren't well established, I will say. Like, we bought the absolute smallest ERVs on the market, the absolute smallest heat pumps on the market. We were constantly dealing with products improving themselves and then having to redo our design to get the best product. And an example of that is that the building was actually designed with exterior roller shades to mitigate solar heat gain. But when we came to construction, the shade company that we had specified, which was super slick, it was going to be on a building sensor system where when that facade came into the sun, if solar heat gain was not wanted, the roller shades would close. And we were pretty excited about just this dynamic quality for the building. But when construction started, the shade company went out of business and left us in quite a scramble to still meet our energy targets, still meet the look of the building that we had promised to the design review board, and still have a comfortable building from a solar heat gain perspective. But what we were able to do was actually upgrade our windows to a really low solar heat gain coefficient, therefore letting in very little solar heat gain, and then switch to a high efficiency heat pump that provided both heating and air conditioning. And we were actually able to meet our energy targets in that way, which I think was pretty impressive. I wasn't expecting that.
So Pat requested seeing the smallest unit. So we just went from the biggest unit to the smallest unit. This is a studio. And one thing I'm noticing that is pretty fantastic is how much casework there is and how much storage. I mean, that's pretty unusual, I think, to see this kind of thoughtfulness around providing storage in a studio unit. I feel like I could actually feasibly see myself living in this space with all of these closets. This is actually more storage than I think my kitchen has. This is pretty amazing.
It's mine too.
Like,
we definitely discussed that, and I think the studio has the most casework because of the storage requirements. Mm-hmm.
Yeah, that's pretty cool. Any other? I'll just click through maybe this. Oh, there's a furnished one. Let's look at that. I'm not sure if this was mentioned yet, but there is, oh, I haven't seen these yet. There's a level of hotel units. Do you want to talk about Sonder, Emily?
Sure, yeah. Interestingly, a hotel company approached the developer about renting a floor of units, and they went ahead and did it. So one floor in this building is kind of Airbnb style hotel, and they've been doing very well in the coronavirus because it's such a healthy building, and because of the air compartmentalization between units. Like, each unit has its own air, its own supply, its own exhaust, and there's no shared air between units. It's been doing well, but an interesting kind of business for an apartment building.
I'll just pull up their site and show you all. Yeah, apparently this property is their highest rental price per night of any of their properties. And I don't know why that is, if it's the location or if it's because of the, the passive house building. But yeah, they're very happy about having this property in their portfolio. So, but yeah, so you can stay in this building is the long story short.
Yeah, sleep in a passive house. And frankly, and with the smoke as it is today, that'd be very appealing.
Yeah, and actually, I was looking at it at the prices, and they have specials for if you book it like the last minute, the price seems to go down. Sometimes you get little discounts and things. So
noted.
Just a little heads up there.
Vacation.
Yeah, exactly.
Mark, the owner, has some indoor air quality monitors in the building, and it links with his phone. So he's constantly, he's at his house or in his office or whatever, and he's checking his phone to see what the quality is inside the building. And it's pretty cool that with the ERVs turned off, you see one level of CO2, and then when you turn the ERVs on, about an hour or 2 hours later, you see the level of CO2 actually go down to about a third of the original amount. And that's super exciting because, as mentioned in the video, there are studies that link CO2 levels with cognitive performance. So it is a healthy interior environment. And the ERVs currently have MERV 8 filters, which is kind of a basic level. We foresee the smoke, but I just learned this morning that they've ordered some newer, the ERV will take up to a MERV 11, and I think MERV 11 filters out smoke almost entirely, so they're in the process of upgrading. But that's the smoke levels. Mark was checking the smoke levels. You could see that the parts per million of particles above a certain size, forgive me, my units are not accurate. But there was a line item on the indoor air monitor that said at a level of 2 parts per million on a smoky day. Was it the next slide that was his ERV on I think these were taken from yesterday. When we were meeting, he's like, oh, I'm gonna check it right now. Yeah. And I don't have a baseline for what other buildings are inside, but I do know that outside, the forecasts are saying it's, between 200 and 300 parts per million. So have an indoor air quality with 2 parts per million. You can see it there, PM 2.5. It says 2. Yeah, it's that line item. So that's pretty cool. I was there right now.
And I guess this product is called Yoo-Hoo. You can see up here. It's an app and a monitor that you can buy. And I guess it's fairly affordable. So you could buy it for your own home if you wanted to be tracking your indoor air quality. I'm not going to do this because I think I would be horrified to learn what my indoor air quality is. So. I guess it might be good to know.
Yeah, as I say, coughing. Yeah. Tell us about the mural, Mark.
Yeah, so Amaterasu, God of the Sun. It's the artist is named Findak, and if you want to be inspired, you can check out his Instagram. It's FINDAC, and he's from Ireland, but he lives in the UK now, and he has done, essentially he's famous for doing these geishas, or pseudo geishas, right? They always have the geisha mask on, and that's kind of his signature. And he's done them all over the world. He's done them for government projects, nonprofit, they're typically in city, and a lot of them are huge. He's done some that are pretty significantly bigger than this. Yeah. So I think the Peruvian government hired him to do one of their buildings downtown, and there's some pretty cool things. He's done them, I don't know how many countries at this point, but.
And Solterra has one more on your building down in Portland that has, there she is.
Look at that. So this one, we always do, when we do one, we love to incorporate art. And this one maybe was a little ambitious. The hair is 1,000 live plants, but it's essentially a living wall built into the facade with its own irrigation system, and then he painted around that. So it was quite the feat. And this one is about the same size, actually. It's very similar. They're both about 70 feet tall.
I love how the mural both ties in as Amaterasu. She's the sun goddess, so she ties into the Solis theme and the Solterra. We've got a sun kind of theme going, but also ties the building into Capitol Hill and all the arts culture that's happening there. We could have just had a big blank wall that performs very well from an energy standpoint, by the way. But kudos to Solterra for really stepping it up and making it an iconic aspect of the building. I hope it never gets covered up.
Yeah.
It's
Trying to find the
it's on the zero lot line, as we know. So we're hoping that it actually is a benefit to whenever the project next door gets developed, which we would love to do. And we're talking to the owner, but it's yeah, but she's in the hospital at the moment, and so it's not the right time to figure that out. But you know, it could be something where if you set back a little bit, instead of staring at a blank wall, then residents who live there will be able to stare at this. They may get sick of it after living there a year, but it'll be it's certainly better than staring at a blank white wall.
Absolutely. And I think that the power of art in the neighborhood, you know, we get so attached to it and so excited by it that it becomes really part of the neighborhood, and it becomes very people want to preserve that. Not to get too off topic, but Weber Thompson did a building down the street called Pike Motorworks, which is right next to Linda's Tavern, if you are familiar with that establishment. And they have a mural there that's well loved and well known. And it was very much part of the building massing of Pike Motorworks to preserve the mural and preserve visual access to the mural. So they actually built a courtyard right next to the Linda's mural so that it could be preserved.
Mm-hmm.
One thing I was just going to point out is that it has integrated lighting, which changes as people walk by on the sidewalk. Is that true?
It will be true. We
Oh,
are
okay.
waiting. Yeah, we are waiting for a piece, but
Got it.
you can see where it's going to go. Yeah, the lighting works. It just doesn't trigger yet. It's just on at night at this point.
Got it.
I would love to hear from some questions, or what the experience level of interest and experience of everyone in the room is, and what we might speak to. We could always play that video again, but I'm gonna have to log off pretty soon and get on with my Saturday. But anything in specific that we can talk to? Size of the units. Oh, the average size is 560 square feet, thereabouts. Mark, do you know the range from the studio to the 2-bedroom off the top of your head?
Basically from 475 to almost 900.
So pretty urban.
Mm-hmm.
Yeah,
There's
definitely, and you know, it's during lease up, it's always interesting. The most popular units are either, you know, the very smallest or the very largest, and
That's
the middle ones are the ones that are, you know, it's an interesting time with how many people are working from home. I am actually certain that that's the reason, because the middle units used to be the most popular.
That's very interesting. Yes, so we have the code required accessible units, 5%. All of the units stack from floor to floor, and even between the accessible and the non-accessible, we just had the walls stack for simplicity, or at least plumbing and bearing walls stack. And then
for ADA units, we have more than 5%.
Oh, really?
At the moment, yeah, because we have almost 10%.
Oh, if you're counting the whole stack of, tell me more.
We had to, because Sonder took the floor, we had to increase the number. And
good memory. Thank you. Yep.
So anyways, yeah, we have so we have one of each type, essentially.
Yeah.
There are 1-bedroom units, and there's 3 floor plans of 1-bedroom. There's a studio floor plan, there's a 2-bedroom floor plan, and there's a 1+ den floor plan. And the
one of each type.
One of each type. There's only 1 2-bedroom remaining that's available. It actually happens to be the ADA unit. And it's amazing because it's got great views. It's got great southern exposure. And then there's all of this kind of is a testament to the size, right? The 1+ den, which we changed mid-construction, if you remember, from a 1-bedroom. It was such a large 1-bedroom, we made it a 1+ den. Those are all leased out. They were the first to go, essentially.
Yeah,
That makes sense.
Yep.
Totally. Joyce, thanks for the questions. Only the south side has a balcony. That is correct. And
no, the second floor east side also has balconies.
A terrace versus a balcony.
Terrace,
yes, you
right,
are
yeah.
correct.
Emily
Outdoor
is
access.
knows too
I'm
much.
being too narrow-minded in my vocabulary. Yeah. Thanks. The bolt-on balconies that you see on the south side were really great from they shade the windows from solar heat gain, so that's good. However, we also took paid a thermal penalty. Passive House requires you to model any thermal bridges above a certain threshold. So we actually had to model when we had something like a bolt-on balcony where we have metal going all the way through the wood wall, and we'll have a thermal penalty associated with that. So that is one of the reasons why we have limited the number of balconies on the project. And also there was a fiberglass thermal break plate installed at the balconies to reduce the thermal bridge. But to Mark's point, we also have terraces on level 2 that are glorious.
Well, that fiberglass plate gave us a lot of problems from a cost perspective. Those are the most expensive balconies I think we've ever done.
That is great feedback. That is great feedback.
Maybe figure out how to cantilever next time and do portholes. But you have in Seattle, there's a thing called FAR, and it's a penalty that you get. It's an HOA fee if they are condo. They're not condo. They are apartments. They were gonna be condominiums for a moment. We kept the condo market was difficult, and so we decided to just keep them as apartments. And on top of that, the interest rates came down so much that it also made it more feasible to build such, a spectacular building and keep it as rentals without charging an arm and a leg for them. And
but you paid for the condo premium. We did a condo upgrade package that added AC, added some acoustic mitigation. What else was part of that package, Mark?
Well, every finish in the units
finishes upgrade.
yeah. So
yeah.
Home
and appliance
floors,
upgrade.
Blomberg appliances, custom cabinetry with exposed plywood edges, things like that. So it's much higher grade than your typical apartment. The flooring, of course, got dramatically upgraded as well.
Tell us about the rents that you're able to get because of these upgrades.
Yeah, I mean, we're getting premium rents. I would say we're not trying to break everyone's bank, though. You get lots of benefits with that, including lower utility bills and things like that. So
and
we're
super healthy air.
We're about $4.35 a square foot if you want to have a basic rent number. So a 500 square foot unit is $2,200, $2,300 kind of range.
Mark, do you have the cost of construction per square foot number off the top of your head?
A lot.
But
I do have that cost, and
I know you have it, but
that cost is, hold on, I have to do. I'll say this: I just need to add sales tax to what I know the number is. So, yeah, we're approaching 350. Hard cost, just hard cost. Total cost is 800. I mean, it's really high.
Wow. I did not know that. Thanks for sharing those numbers. That's very interesting.
And that's, look, I think the reason that the costs are so high, you've got numerous factors. Number one, the Passive House premium. Number two, the finishes premium. Number three is there's not a lot of parking in the building to offset the square footage of the expensive space. And the things that we did that are outside of the square footage were really expensive, right? We, redid all the sidewalks, all the ramps around it. The rooftop deck is like no other.
Oh, it's amazing.
Like so
well, we haven't shown a lot of pictures of that.
You wouldn't call square footage. And yeah.
So the moral of the story is it's really expensive to build in Seattle right now. and only a little bit more to go passive house.
Yep, yeah. The actual passive house costs were not huge.
Yeah.
The condominium style upgrades, things like that were probably more. And then I think some random, city obligations, essentially, when they decide, hey, redo all the corners, and that was never in the plan, things like that. But
Totally.
It looks beautiful out there now.
It really does.
Oh, and adding things like a mural, that's not cheap.
Mm-hmm. Yeah.
Oh, that's a cool image.
Yeah, this one really gives you the sense for how close it is to CHOP, because wasn't the boundary like right here?
Mm-hmm.
Yeah.
Our dumpsters, the day they got delivered, our dumpsters were commandeered.
Wow.
Because the building received TCO, approximately 7 days before CHOP formed. And so then the dumpsters get delivered and they never made it into the building.
Oh man.
Mm-hmm.
Wow.
And now they have some interesting graffiti on, which I'm actually remiss to paint over because I feel like it's a part of history and there's not that much that's left over anymore. Almost everything's been painted.
Huh.
There's just a couple of choice phrases that I think I might have painted over.
Oh, you probably can't repeat them here, but I would love to see a photo of that.
Yeah, definitely take pictures before you paint over anything.
The ones that have the word kill in them are coming off, but there's
wow.
some other ones that are more interesting, and they're the painted fist and things like that.
Wow.
I think we will keep on there.
Yeah.
And that was another interesting thing was the only graffiti we had on the building was essentially the painted Black Lives Matter fist. And people essentially, I think, respected the building. Everything else around us just got covered. People respected the building enough because of the art that was already on there.
Wow. Interesting. That's cool.
I thought the boundary to CHOP was just right next to the building, the cuff, the building that has the rainbow lights on it.
Yep.
They had the blockades right next to the rainbow.
So the blockades were at one time in front of Solis.
Oh, were they? Oh,
yep.
Wow.
Then eventually they did get moved back one block. So if you went one block either to the west or to the north, you were in CHOP. So we were like the first building outside of CHOP almost.
Oh, there's a request for a, oh yeah, beautiful.
Lori, the close-up is walking over to Pike Street. You have to experience the mural in person. We have yet to come up with an image that does it justice. It's enormous.
There's a question about adjustments for future buildings because of COVID.
Yes. So funny enough, this building just hit the nail on the head with regards to COVID. It has individual ventilation for units. The units are separated by air. All the spaces are, all the amenity spaces are outdoors. All the common area spaces are outdoors. It's kind of like, how could you have even decided to do that? We did it for energy reasons, not for COVID reasons. The two just happened to coincide perfectly. For our, and so this building is actually about 30% more ventilation than code. And you don't really want to go more than that because it can cause dry eyes and dry skin and things like that. We spent a lot of time thinking about this, and this building actually has adjustable. So we can go down to code or we can go up to as much as about 40% above code.
Interesting.
Yeah. Sorry, do not disturb. That's the only way I'm getting this happening. There we go. It's my daughter's birthday today, so everyone is arranging stuff via text.
Thank you for being here on your daughter's
birthday. It's really unfortunate because there was an outdoor birthday party that is now going down and it's going to be staggered throughout the day, starting at 2.
Yeah.
Indoors, so it's going to be tough.
Oh,
but yeah, so other COVID related stuff we are doing as this building is, it's 100% outside ventilation, so no recirculating air. That is already what Solis is built as. It is not how we have built other buildings because it has not become standard at all. Our next project is 100% outside air as well, with
have MERV 15 filters for all outside air before it gets to the units or the common areas. So that's the biggest thing. The second biggest thing is the ability to social distance.
Mm-hmm.
And so, you know, again, I think Solis, very interestingly, if we have a picture of the rooftop, like more.
Yeah, let me share. I'm gonna pull up a different screen here. Hold on.
The rooftop has kind of 4 distinct areas for people to gather that are all 15, 20 feet away from each other. And it allows you to have small groups up there that are intimate, though you can kind of see it there. So one is on the right side and there's cooking and dining right there. There's lounge over on the left side. There's a fire pit with a roof over at a pergola that is watertight, but also is louvered so the sun can come through during the summer. And then there's the center, we call Tree of Life concept. It's an 80-plus-year-old Japanese maple from the center of Oregon that we drove up personally because we wanted to have one very special plant within the building. That's it. I'm not sure, I'm trying to think of anything else COVID related. Touch-free, right? That's the other thing that people are planning for. So, you know, touch-free is tough in some areas. It's difficult on common entry unless you want to have kind of grocery style doors, and they really take away from the ambiance. So we are looking at that, but we haven't decided on how we're going to kind of improve safety from that standpoint. Touch-free elevator, we are looking into, where it reads your fob and just sends you to your floor. Yeah. Okay. Overlap between touch-free and ADA. Well, maybe. At the moment, all mechanical systems, including access control systems, are they have to be at ADA height and ADA accessible. So everything we do has to meet, you know, code from that perspective. And I think that the touch-free systems will be easier for people that are in a wheelchair for sure, or mobility disabled in some way, because it's just one less thing to fumble with. All the other ones, you know, you still do need to have a fob or your phone, and we're working on where you just, you know, put your phone near so you don't have to constantly get a fob out. Motion sense versus physical contact. Yeah, so you don't have to touch anything, but the doors, that's the thing that I was kind of mentioning, where doors that automatically open do have thermal issues. They typically, you know, if you go to a grocery store, often they have the kind of wind curtain, they call it. So we're looking into it. The hardest portion of this is that front door, common entry doors are very difficult to do in a way that is both kind of homey, and so it doesn't feel like you're walking into a grocery store or an office building, but also safe. And I think we haven't, honestly, I'm not sure that anyone's come up with the right solution for that. The one thing that we will definitely be doing is where you can do a non-touch ADA button to open the door if you like. So that allows you to not touch anything and walk through if you're, you know, concerned about that. But then most people will just pull the door.
We're just curious, you know, Solis is a little bit different than other projects on the tour since it's a multifamily building. So, you know, I know a lot of folks, it sounds like, yeah, Lori says, I want to make my house as energy efficient as possible, planning a residential remodel.
Yeah, it is difficult. Yeah, so I can give you some tips because I've done a number of energy models at this point for various buildings, and just kind of tell you, the number one thing is insulation. Best bang for the buck, always. Windows, actual insulation, and keeping a building, you know, taping the drywall, or you, like this building actually has a liquid, kind of like a liquid rubber barrier that was painted on the entire building So that's more than you want to do, most likely. But that's the number one bang for the buck. That's how we really get to passive house standards, is making it so that every BTU of heat that goes into the building or cooling stays inside. That's the number one. And then outside of that, having a very efficient heating system, of course, and cooling system, which heat pump is the way to go. You can always go crazy and go geothermal, but your biggest bang for the buck is just switching over to either vented or non-vented mini split systems. And then outside of that, it's actually water heating. Water heating is a really big one that most people overlook. It's more energy saving to use a heat pump hot water system than to put ERVs into your house, actually. And that is a big shock because it's so much easier to do the heat pump hot water than to do the ERVs. The ERVs give you a lot more than just energy savings. Sorry. Better air and things like that. So they're much healthier, especially right now. I wish my house had ERVs really badly right now.
Sorry, I don't know what an ERV is.
So that's energy recovery ventilator or ventilation. And so so right now, most likely the way your house gets any kind of internal air, there's a picture of one, we have one of these on every floor, is you have a fan that sends air out of your house, and then through all the leaks in your house, new air comes in. That's actually unfortunately, how most of these work. It's actually the same thing that almost every apartment building, other than high rises, because high rises can't do this, they use these things called trickle vents. So the windows have these tiny little holes in the bottom. And so when your bath fan comes on or you turn your hood on in an apartment building, it creates negative pressure because it's pushing air out a pipe, and then regular air just comes right in through the windows and other leaky areas. So what an ERV does instead is we seal all those little holes, and then we have one in pipe and one out pipe. And so air is coming in, going through a filter, and it's going through a heat sink. That then, so if say the outside air is 50 degrees and the inside air is 70, it equalizes the air pressure so that the inside air is now 69 and the air going out goes from 70 down to 51 or so, right? It's not perfectly efficient, but it's like 70 to 80% efficient depending on your system and how much you're running it. So now you're getting fresh filtered air that is recapturing the heat that you've already spent money on, or the cooling. And that's essentially what they do. And so essentially can give you better air and it can save you money on heating and cooling. And so this building has all those.
Sorry, question about that. So you mentioned something about, I think you called them trickle valves on the windows.
Yeah,
so if you're replacing all your windows, would that be a different kind of window you'd order that didn't have those if you were planning to go to ERV at the same time?
For a single family home, people don't typically need trickle vents. There's enough leakage in the house to accommodate. A lot of it comes through the floor, a lot of it comes through around the windows, through the millwork, things like that. Places you wouldn't believe. But also people are opening windows and doors, and opening your front door lets in huge volumes of air. Mm-hmm. So you wouldn't necessarily need that. Now, if you were attempting to retrofit to a passive house, I think it's pretty tough to do that. What I would be more focused on is the insulation value if you are trying to add this to a home, because you're never going to get away from the leakage, right? You've got it in all these other places and your windows. If you just replace your windows, you're not going to get around the leakage, but you can get away from the, how much energy loss. If you have single pane windows, it's just, they don't even insulate almost at all. They're like almost a 0 R value, versus triple pane, they have pretty significant insulation within them.
Thanks.
Mm-hmm. Are you guys both interested more from the single family side?
Yeah, I am.
Yeah, I mean, single family passive houses are becoming exceptionally popular. And there's a lot of reasons. Obviously, you can save money. But I think most importantly, they don't cost much more to build. But most people are doing it from new build. It's exceptionally difficult to retrofit a home because it's really inside the walls where it starts.
Yeah.
Where,
Yeah, no, I'm not my goal isn't to be Passive House certified. My goal is just to improve the envelope of my house.
yeah, so, you know, insulation number one in the walls, right? And there's lots of ways to do that pretty easily. People can do blown in cellulose or fiberglass insulation, which it performs amazingly well. And then windows. And then obviously the big one is the roof insulation. That's, you know, that's 60% or something of your heat loss is going to go up. Cooling loss is the opposite, but depends on if you have a basement or not, right?
Yeah.
If you want, then, you know, and every house is different, right? But if you have circulation problems where it's like, oh, it's hot over here and cold over here, that's where ERVs can come in handy because they really move a lot of air around and they keep the air really clean. And so that only, you know, not only will improve your general air quality, it'll lower the CO2 in your house, things like that. It'll make it so that cooking smells go away much faster. There's lots of different benefits to doing that. And then it's really, where are your heat sources? So your heating, your cooling, both hopefully, or heat pump, that's easily the best bang for the buck out of everything we've talked about, is heat pump and insulation, and then hot water. And hot water really can be a big one depending on how much water you use. For multifamily buildings, it's the second biggest thing after your main heating source, especially in Seattle, because we're pretty temperate. But our hot water, you know, our water still starts at about the same temperature as if you were in California or Alaska. And so you have to heat it up to what's comfortable, 110 or 120 degrees Fahrenheit.
Yeah, well, thanks.
This one's a big energy waste right there. We only have a couple natural gas uses in the building and they're all outside. But we really do our best to blend, you know, that luxury feel. For me, you know, my biggest thing that I want to focus on for future projects, and I've tried to retrofit this project as much as possible, is how do you create comfortable outdoor spaces that can be used more than 9 months a year without just blowing energy? Because gas heaters, even electric infrared heaters, you wouldn't believe. I mean, that's like having 3 or 4 electric cars plugged in. It's crazy how much energy they use. Yet everyone is now, I think, even more than ever before because of COVID, is starting to appreciate how outdoor get-togethers can be so nice. And especially if we don't have some sort of real vaccine or whatever coming up. And so that's the next thing that I'm focused on personally. And it's kind of, I think, pet projects within our projects. And I mean, I'd be curious about what you guys are thinking about that sort of stuff. I'm looking at actually using heated furniture and heated ground so that the heat stays lower instead of coming down from you, from above, where it's having a hard time getting to you. And only far infrared can really get to you and penetrate. Yeah, so far, heated sofas and things like that, they're made out of stone. So they're not super comfortable. And so we're trying to figure out, you know, what are the other methods here that we can, you know, come up with increase the comfort while not fully enclosing a space.
Yeah, lots of opportunity for innovation.
Yep.
Very cool.
Lori, you're the last person standing. We're coming up on 3 minutes left. Do you have any last questions?
No, this has been very helpful. Thank you. And thank you for customizing our questions. I appreciate it.
Of course.